Okay, so for the think about it, we have two equations to solve. So the first one says 4x plus 3 equals 11. This is a regular two-step equation. We start on step 4, which is get the constant on the same side. I need to get rid of this plus 3 by doing the opposite. So I'm going to subtract 3 here and here. And that gives me 4x equals 8. Isolate the variable by dividing. X equals 2. Doesn't ask me to check, so I'm not going to check. That's a pretty simple one. Same thing for equation B, 2 steps. Get rid of the positive 6 by subtracting 6. So 8x equals 16. Isolate by dividing by 8. And again, I get x equals 2. So on the next slide for you is asking you, what do you notice about these two equations? Well, I notice that the solution is the same. The solution for both equations is x equals 2. That is the solution. What else? Well, let's look at what we started with. I had 4x and 8x. Those aren't the same, but they're close. And then I have 3 and 6. So what's the difference, or what's a pattern with 4x and 8x and 3 and 6? Well, to get from 4 to 8, I would multiply by 2. And to get from 3 to 6, I would multiply by 2. Then if I look at 11 and 22, it's also being multiplied by 2. So the whole equation got multiplied by 2. So for the second question, what is the relationship between the two equations? So equation 1, or the first equation, was multiplied by 2 to get the second equation. Something along those lines. Complete sentence starting with a capital, ending with a period, letting me know that we multiplied by 2. If you wanted to start with equation 2 and say everything was divided by 2, that's perfectly fine. I just started with equation 1.